To get a little bit more into writing these double replacement reactions into practice is what we're going to look at now. Is anytime you add two compounds, right? It's made of two elements or a metal, usually metal and a non-metal, or a polyatomic ion. What you're going to do when you write your products is you are going to switch the two first ions. So like the A is going to replace the C and the C is going to replace the A. So they switch places. So now I have AD and CB. Okay, make sure that you always list the cation first. Okay, and if I gave you the compounds, they are listed that way. So it's always positive and then the negative thing. Now, again, and I'm going to reiterate this a bunch of times, check your charges when you make your new compounds. Okay, so you need to check your charges based on your periodic table. What column are they in? What is their charge? Don't copy the subscripts over. So if it had a little 2 over here, that does not necessarily mean it's going to have a little 2 over here. You got to check those charges. So check the charges of any new compounds you make. Anytime you put something together, check those charges and then balance it. So don't try to balance while you're writing the products. Write these first and then balance. Okay, so we've been talking about precipitation reactions. There's actually 3 different types of double replacement reactions. You could make a precipitate, which is what we have been doing and talking about. You could also make a gas, or you can neutralize and make water. That's what happens in acid-base reactions most of the time. Okay, so we had been looking at making solids above. So I want you to try to these ones and writing the molecular and net ionic reactions for the following double replacement reactions. Now, in order to write the net ionic equation, it might be easier for you to first write out the full or the complete ionic equation and then cancel out the spectator ions. But if you know what the solid is, you might be able to write the net ionic equation without writing out the full one. And really, the net ionic equation is the one that I care about. So what I want you to do is write, this is your AB and this is your CD. Make sure you switch your first 2 ions, check your charges, and then balance. So give that a shot here for A, B, and C. And then I do want you to draw C. Draw what you started with, 2 separate beakers, and then what happens when you put them together. Okay, so hopefully you paused and did it. When I switch these, I switch the Na is now with the Cl and the Mg is with the S, but then I have to check my charges. Magnesium is in column 2, so it's +2. Sulfur is in column 6, so it's -2. So this is good, MgS. And then when I put Na and Cl together, they are +1, -1, so they are NaCl. I did not take this little 2 with me. I did not take this one with me. But now I have to balance, so I put a 2 in front of the NaCl. Okay, so I made these, then I have to figure out which one is my solid. Well, NaCl, if I look at my solubility rules, Na is always soluble, so this is aqueous. Then that must mean that this is my solid. This also falls under the sulfide rule. If I go back up to my rules, if it's got sulfide in it, most sulfides are insoluble unless they're with rule 1. So that is my solid. Okay, then the net ionic equation is what makes the solid. So the Mg2 plus the S2 minus makes MgS solid. Okay, these do need the charges. Notice they are ionic. You have to have the charges. Okay, then they get a little bit more difficult. So you had to switch your ions. So in this case, my potassium is going to switch with my chromium, this guy. And then you need to check your charges. So K with Cl are +1, -1. And then Cr with CO3. Well, CO3 is a carbonate ion. It has a -2 charge if you check your polyatomic ion sheet. And chromates is one of those transition metals. So you don't actually know its charge unless you look at the compound here. Okay, so it had 3 chlorides, so it had to have been, if you like reverse the crisscross, chromium had to have been +3. So this was +3, this was -2, so I flip-flopped and got Cr2, CO3, 3. Okay, now the good thing about all of these double replacement reactions or these precipitation reactions is that the charges don't change. So whatever the charge on the left was, it's got the same charge on the right. All those ions have the same charge. It's just that you're putting different things together, and that's why you have to double check your charges. So then I check my rules. I'm like, okay, KCl is my aqueous one, chromium carbonate is my solid one, and then I had to balance, so 3, 2, 6. Then for my net ionic equation, again, my solid should be my product. So I'm making my solid. So what ions made my product was 2 Cr3 pluses and 3 CO3 2 minuses. That would be my product. Okay, same thing down here. I should have made a cobalt hydroxide, and this is going to be my net ionic equation. Now, drawing it, again, I like drawing it out so you can see what's going on in solution. What I do is I draw the first substance in one beaker, the second substance in another beaker, and then the products when I have mixed them all together. So at first, this is cobalt 2 nitrate, which is aqueous. So it has a 1 cobalt and 2 nitrates floating around. Then after I balanced this had 2 potassium hydroxide, so 2 K pluses and 2 OH minuses. And then when I mixed them together, what happened? Well, I made this solid, so I should have COOH2 settled at the bottom. That's my solid. And then my spectator ions, my potassium nitrates, 2 potassiums, 2 nitrates, the 2 goes to the whole thing, are floating around. And you'll notice I didn't lose anything in this reaction. This is balanced. I had 2 K pluses. I still have 2 K pluses. They're just floating around. 2 NO3 minuses. And then I've got my solid down here. So that's what your drawings should look like if you are going to make one of these precipitation solutions, and tell me what it looks like.